Hi guys, it's the Fire Lady, and today we will be discussing enzymes and substrates. So, enzymes are basically proteins and they are biological catalysts that actually help in certain processes such as digestion, and it basically makes the process faster. All right, and a thing to remember about enzymes is that they have something known as an active site, and that's where most of the reactions occur. All right, the active site is a key word in the exam, especially when you're doing a paper. If you don't mention the word active site, they don't know where the reaction is happening. So it would be ideal if at all you're writing an answer regarding an enzyme to mention the active site, because that is where the reaction occurs. And a substrate is basically the substance, or we can say it is like a molecule that binds temporarily, so it's not there permanently. It binds to the active site of the enzyme. And yeah, so that is the substrate and that is an enzyme. And over here, you can see how an enzyme looks. This is how an enzyme looks, and this is the active site. And this is where the substrate's going to bind. And this is how your substrate looks like. It has the same shape as the active site. So we can say that each substrate is specific. So the key word over here is specific. So only if the substrate has the same shape as the enzyme's active site will it bind. And that is how the reaction takes place. So once it binds, that's how it looks over here. It's termed as an enzyme substrate complex. And the enzyme substrate complex basically is the substrate binding into the active site of the enzyme, hence allowing the reaction to take place. All right, only if it binds will the reaction take place. So that's a bit about enzymes, substrates, and the enzyme substrate complex. So whenever you're writing the exam, always mention that once the substrate and enzyme have bound, the term we would use is the enzyme substrate complex. All right, that's a key term that I have seen in many mark schemes, and it's ideal that you would use it so you can show off to your teachers saying that you know a lot about it. All right, so again, the enzyme is complementary. That's a new term. So complementary basically means the same thing as specific. It means that they will bind. So that's how it's going to be. So they are going to bind to the, the substrate is going to bind to the enzyme, not the other way around. So always keep that in mind. And so there are two models that explain the enzyme substrate complex. All right. So the way the enzyme binds to this, the way the substrate binds to the enzyme, there are two models that explain this. The first model is the lock and key model, and the second model is the induced fit model. So let's take a look into what this lock and key model is. So the lock and key is really similar to the door lock and the key we have at our homes. And it's basically, let's just imagine the enzyme to be the lock and the substrate to be the key. All right. Only if the key is of the right size will it ever fit the lock. So if we don't have the right substrate, it's not going to fit the enzyme. Hence, the reaction is not going to occur. And if we have the right substrate and the right enzyme or the lock, the door is going to open. So when we say the door is going to open, it's similar to saying that the reaction will occur. All right. And things to remember about this model is that the enzyme and substrate will have a fixed shape. All right. So the shape of the enzyme and the substrate is fixed. You can't change it. That's why it's similar to the door lock and key, because we can't change the key or the lock. We need it to be of a particular pattern in order to open it up. So that's the lock and key model. Then you have the induced fit model, and the induced fit model is basically the enzyme's active site will slightly change its shape to properly fit the substrate. So if the active site looks like this, you can see it's slightly curved, right? But we can see that the substrate has like really sharp edges. So once it binds, the enzyme will bind the substrate, and you can see that it's changed to fit the substrate's square kind of shape. So from this curved shape is changed into a square kind of model. So that is an induced fit. So induced means it suddenly changes in order to match the substrate. So that's the difference between the lock and key and the induced fit model. The next thing is that there are three factors that actually affect the enzyme. So that is your temperature, your pH, and the substrate concentration. So let's discuss each of them individually. So we have the temperature, right? So if the temperature, for instance, is low, the enzyme activity is going to be slowed down. So if you don't have a high temperature meaning not too high, it should be the correct temperature. So if you don't have the correct temperature, the reaction is going to be really slow because the enzymes don't have enough kinetic energy to collide with the substrate. So you're going to get less enzyme substrate complexes. So therefore, there's going to be a less reaction. And the next thing is if the temperature is high. So if the temperature is high, the enzyme's activity increases. But if the temperature is too high, that means like really high, around like 100 degrees Celsius, then you're going to have a problem because it's going to denature the enzyme. So that's another key word which the mark scheme looks for, denature. All right. So this is how it would look on a graph. You would have the increasing temperature. Then when it's like really high, the rate of reaction is going to fall. So the rate of reaction increases as the temperature increases, but the optimum temperature causes the reaction to happen to its maximum. So optimum point is basically, let's look over here. The optimum temperature is basically the maximum point at which the enzyme works the best without denaturing the enzyme's active site. So beyond this point, so if it goes beyond the optimum temperature, then the enzyme is going to denature, as we can see over here. It's going to denature and the reaction is going to just decrease. All right. And so let's just explain what this graph shows. So the graph basically shows that if the temperature increases, the enzyme and substrate will gain enough energy to collide. So there's a high chance of more enzyme substrate complexes being formed. So there's more chance for the reaction to happen. And if the temperature increases too much, so that means if it's way beyond the optimum point, the bond within the active site, they break. So key thing to remember here is that the bond of the active site is going to break, all right? That leads to it being, that leads to the enzyme being denatured, all right? And so then your reaction is not going to take place because the substrate is unable to bind to the active site of the enzyme, all right? So the word denatured is explained over here. So many people find it slightly difficult to understand what it is. So it's really simple. It is the enzyme's active site, the one which was shown previously in the diagram. So that gets destroyed. So when that gets destroyed, it basically means the shape kind of goes out of place, and the substrate does not bind to it because it's not the perfect fit, and then you have no enzyme substrate complexes being formed, and hence you have no reaction. All right, so that's how it works. And then you have the pH. So if the pH is too low, when I say too low, I basically mean if it's in acidic conditions. So like a pH of 1, 2, or 3, these are considered like really acidic, and the enzymes are not going to function, and that's because the active site has been denatured again. So there are many ways in which the active site can get denatured, and it's best to know it by heart. So that would be the high temperature can denature the enzymes, active site, a low pH can denature it, so can a high pH denature it. So this is how it looks on a graph. So this is how it looks on the graph, and this over here is your optimum pH, and so the lower the pH, the enzymes denature because the active site bonds, they all break up because of the strong pH, and you lose the shape of the active site, and then the enzyme and substrate cannot bind, and you do not get a reaction. Then you have a high pH, which basically also distorts the active site bond, and it makes the enzyme inactive, so the substrate cannot bind to it. So things to remember is if it is before or beyond the optimum point, the enzyme isn't going to function effectively. It may function for a bit, but not as good as when it functions at this optimum point over here. All right. And the last and final thing is basically your substrate concentration. So if there is less substrate, that means if there are not enough molecules around, the enzyme substrate complexes are going to be formed in less number. So there's going to be less reaction. So there would be a reaction, but not as good as we expect it to be. And if there is an excess of substrate, excess means too much, way too much than we need, all right? And so what happens is that the key thing to remember is that the enzymes all have a limited number of active sites. So for instance, maybe an enzyme has only 2 active sites, so it can bind to only 2 substrates. So if we put 4 substrates into that solution, maybe it's going to bind to only 2 of them. So that's a problem. So the other 2 substrates are in excess. So what happens when we have a situation like that? So the active sites will obviously get full and booked. It's like going to a hotel and they tell you that you don't have room because they're all booked. So it's similar to that. And the active sites are basically booked, or there's no space for them to bind to more substrate. And what happens is that if you increase the substrate concentration beyond the optimum, there's no point actually because the reaction is already taking place at its maximum. So if you increase the substrate concentration, nothing's going to happen. The reaction is just going to remain as it is, as it was at the optimum point. So the key term to remember over here is that the reaction is going to remain constant. This is a keyword because the active site is occupied, all right, by other substrates. So the key word to remember in the exam would be that the rate of reaction remains constant if the substrate concentration increases, all right? But if the substrate concentration is gradually increasing, the rate of reaction increases. But if it's beyond the optimum point, the substrate concentration is just gonna the enzyme reaction just going to remain the same. All right. So that's it from today's lesson.